Good day. Today we are going to be playing around with a project for Element14.com for their DIY test instrumentation. If you haven't been to the Element14.com website, make sure to join. Lots of cool projects and contests and all sorts of fun stuff, road tests that you can take part in. But today we are going to be taking part in this guy here, and basically what we're going to be doing is we're going to be coming up with a project for this DIY tester instrumentation. Seems like a fun little project that we can do here. There's been a project that I've been wanting to make for a little bit here, but if you go to the website you can definitely click under build and it will have Project 14 competitions listed here. You can also check out the Element 14 Presents and a lot of other things, road test and reviews, Raspberry Pi projects, all sorts of Arduino design challenges, and all sorts of other goodness within the community. What we're going to do today is we're going to come up with a project for this. I wanted to come up with a project that could help me in my day-to-day diagnosis of electronics. Now, I do work in the medical field as a repair technician, repairing things from hospital beds to power chairs and all sorts of things. That being said, we come across a few things when it comes to repairing. So a stair lift will use infrared, and something else might use RF frequency. But how do you test these items to make sure that they're actually working? Well, I wanted to come up with something that I could just throw into my toolkit and be able to quickly diagnose and help people quickly as possible, because when a hospital bed breaks down or a stair lift breaks down, you're taking away a lot of their comfort and their mobility from them. So that was my basis for this project today. So with that being said, let's head over to the workbench here and have a look at what we have. Okay, and it certainly helps if you put your lens cap off of your camera. So what do we have here? Well, we've got our breadboard with, well, one of our designs here. So let's have a quick look here, and this is going to be for our infrared sensor testing. So I'm just going to go ahead and try to, well, I guess that's as far as I can bring it down right now. But we'll bring up some examples here in a moment here. So on the board here we have our Tsaw 1738, and then we have our 5-volt regulator, so our LM7805, and then we have a 100K resistor and an LED. And then, yeah, we are just wiring it up here. What I'm going to do is I'm going to bring up a little bit better of a diagram of this. And then I'll go ahead and load this project in there. And with that being said, there is other things involved in my design here, but for right now we'll open it up, and there we go. And I will make this, I'll make sure to post a picture of this in the write-up as well, but just so you have an idea of what's going on here, I'm going to go ahead and I'm just going to zoom in just a little bit just so we can get in close here. We're not going to worry about these guys over here right at the moment. That is for our other circuit here. So right here I'm just gonna bring it like this, and we'll pop it out one here. Okay, so from our battery here we've got our ground wire coming in, and then we have our ground wire coming over to here, to the first pin on our Tsaw, and that's going to be our ground line. And then on our LM7805, the ground pin is going to be that middle pin, and then our second pin here, that is going to be our power pin. So that's going to be our voltage here. And then finally, the third pin here is going to be our output pin. If I am correct, I think that's exactly what I did. And then we're going to go from there over to our LED. We're going to make that light up. With that being said, let's take a quick look here at our workbench here. So I do have this one here, but you did see this one here on that diagram there. I definitely need to get a better lens for getting in a little bit closer. Basically all we have here is 10 ISS86 diodes, and that is what we were seeing over on our fritzing there on our breadboard on there. So basically it's just going right around in a circle from one end of the LED to the other. So now when we actually produce an RF signal, this should be enough power to light up the LED. So for that, I'm just going to go ahead, turn on my radio here, and I'm just going to go ahead and I'm going to just change the lighting a little bit here, so a little bit darker. So got the antenna here, and we're going to keep our eye on this LED right here. So when I press the talk button, we should light up. So we know that this circuit is working. Pretty simple circuit, does a lot for when it comes to testing. So if you have a multiple button controller that you need tested and you're going through them to find that one button that is sticking or having issues, then there you go. You've got a nice little tool to test that out. And that will bring us back to this guy here. So with this guy here, all I have is this really cheap remote that came with another kit, and basically it's going to do the same thing. You push a button once you have power to the board here, because we're going to take our 9 volts and drop it down to 5 volts here. So I'm just going to try to connect this up the best I can and give you an example here of that working. And then we'll go ahead and get going on a little bit more on this. These are pretty basic circuits that anyone should be able to do. So there we go. So now we should have power. So every time I press a button, I should be seeing something happen on. I should see the light flashing. Once again, I'll turn the light off here, and then there you go. And you can actually see when I push the buttons that there is something happening. So this is great. So where do we go from here? This is not practical to carry around a couple of breadboards to work and put it in my tool bag. So what I did was I went on to fritzing, of course, where I was playing around with it there. So I'm just going to bring that back up here. And basically all I did was I built my circuit here of both of my devices here, and then I went over to my PCB and I made this PCB. I routed everything, made everything look perfect. Well, as much as I could. Does it work? I don't know. We'd have to get it printed and check it out and see what happens. That's the great thing about the power of these videos, is we are able to take something like this and be able to bring it back to the workbench here. And I'm just going to disconnect this battery here quickly so I don't short nothing out. we can move the breadboard out of the way, and then we can go ahead and bring in our actual printed board. Now this is a little bit bad on the, let's try to bring that down just a little bit. So something like that. So there you go, we have an actual printed board that we can actually use. I'm just going to see if I can bring that in. There we go. So this is the finished board. It's just a small little board, which is great because we're going to have another 9-volt battery case on the bottom of it there. So when I built this, I wanted something that was compact, but yet something that was going to be, you know, usable. And I think we might have it here. So what I did in this, if you look, I added 2 things to this, and that was I added, no, 1 thing. The 1 thing I added was a switch block. Let me see if I can get that in there a little bit better. So right here I added the switch block. And on the schematic here, you'll see that switch block right here. And this is what I mean by using that switch block there. So that way I'm actually able to take something like this here and be able to mount that on a case or something, and be able to use that to turn the unit on and off without wasting the battery or having to disconnect it every time I want to use it. So that's all we're going to use, this and a couple of other little parts there. Yeah, we got that switch block, and that's just a terminal block connector. So we will put the terminal block on there for the switch block, and then we can just screw into that. So if I can just disconnect it or whatever, but that way we're not constantly feeding power to the IR sensor, because we don't need any power with the RF, so we don't need to worry about that. So what I'm going to do is I'm going to go ahead, I'm going to get this soldered up, and then what we're going to do is we're going to give it a test and see how it works. So I'll make it a little rough, and then later on maybe I'll 3D print a case. If you want to see that, let me know. I'll come up with a case for this. If you want any more information on this, make sure to check out element14.com. Go to the Project 14 section there, and I guarantee you you'll find something in there, and this is for that DIY test instrumentation. So I figured this would be a perfect fit for doing it for them on there. So just so you can see that you don't need to have something elaborate, but you can have something the smaller, like that's even smaller than this little cheap remote here, So it's about 3.5 inches, just over 3.5 inches, and 2 inches wide. So that's not bad. So what I'm going to do is I'm going to go ahead, I'm going to get my soldering iron warmed up here, and we can start placing our stuff. So what I'll be doing is I will be recycling most of the stuff from the breadboards, as I always do. That way I can have those breadboards ready for other projects. So with that being said, make sure to check the link in the description. I'll have it going directly to my post there on this. You'll get more information, all the schematics. If you want to print your own boards, go ahead, get those done up. or design your own. I'd like to see what you come up with, and maybe you can make a little bit better PCB than I can. But you know what, for the amount it costs to make a little PCB like this, you know, I thought, why not? I would pay more for other tools, so in total this did not cost me much at all to make. I think I had everything but the actual 1738 Tsaw. So that is the only thing I actually ordered in, and I ordered in a bunch of other little boards as well to play around with, just to see, but I ended up going with just the standard 1738 for this project. No rhyme or reason, but I feel that you know, the LM7805 are going to be able to fold that down, and then be able to fold the Tsaw 738 down as well, just to make this a little bit more of a flatter design that'll go on top of the battery box. And then eventually, like I said, we'll 3D print a case to enclose it all. That way it's all nice and neat, but we will want to keep these diodes visible to be able to pick up those RF RF signals. So, and getting that. So we will definitely play around with some ideas with that later on, but for today we are just soldering it up. So here we go. Soldering iron is warming up here, so all I'm going to do now is I'm going to go ahead and back this up just a little bit here. I've got my helping hands here, my pan of ice here. What I think we'll do is we'll go ahead and we will start with the diodes on here and then work our way around to the other side here. So I'm just going to go ahead and get this into place here, and then we'll get all those diodes placed, and then we can go ahead and get them soldered on, and then we'll start working on the other components here. So I'm just going to bring that there, bring that here. Actually, we can bring it back just a little bit. Alright. That's a bit shiny. There we go. So just go like that for right at the moment here. And there we go. Okay, so we got that in there. So I'm going to go ahead, I'm going to start placing all of my diodes here. And that's just as easy as taking them off the breadboard and poking them through, and then just bending those legs on the inside there so it doesn't come loose once we flip it over. So I'm just making sure that they're all like this. Is, to me, this will be a good design. We're just going to keep on loading them up. So we just want to make sure all of our diodes are going in the right direction. Okay. And there is no rhyme or reason why I used 10 diodes over any other amount. I just decided that was the amount I would go with. I bought a pack of 20 of these at one time there, and I thought, why not? 10 sounds good. So I'm just going to bend this one just a little differently there. Okay. Okay, there we go. Perfect. Perfect. There we go. So we've got all of those guys in there. I'm just going to go ahead and make sure they're somewhat flush there. And then we'll go ahead, turn it over, and get soldering. And there we go. We've got that. I'm just going to tin my soldering iron, and away we go. this around a little bit here. Ooh. Okay, hopefully those are all in there straight. If not, oh well, not the end of the world. Check the other side here quickly and make sure those are all somewhat lined up. Yeah, that looks all right to me. I'm okay with that. So we're just gonna go ahead and carry on here. So once I get a row of them done, all I'm gonna do is take my side cutters here and just go ahead and cut off the stuff that is not needed. So we'll just go ahead and we'll save those for something else later on. Okay, and then now we can carry on, just finishing those guys up. Okay, that row is done, so I'm just going to go ahead. Again, clean that up. Okay, and these ones seem like I let them down. So I think what I will do one side in, and then we'll get the other side in, and then we'll come back to this side here. Come on, go to your home. There. Sorry you can't see this part here. I legit have to. There we go. Go ahead and just going to get rid of this row, and we'll go ahead hit up the next row. There we go. Just gonna might not be perfect, but hey, we're gonna go with it. we've got that done. Let's go ahead, let's flip it over, have a look. So let's go ahead. Alright, so flipped over. Yeah, I could have done a lot better there, but that is okay. I don't mind that. So I didn't even check to see if these terminal blocks will actually fit in here, so I guess I better do that. I have a whole bag of them, so look at that. That's pretty perfect if I don't say so myself. So we'll go with that. After, what I want to do now is use our resistor here and get that put in to here. And we'll just go ahead, spread out the legs on the bottom, flip it over, solder it in. That, and we'll just go ahead, solder that up. Okay, there we go. Cut that out of there. Hopefully you've seen that. I guess you would have. Alright, so we don't really need to do any other fine tuning there, so we'll just go ahead, solder this guy in. There we go. Now we can go bring that down a bit, and we'll just go ahead and solder that other side now, and then we'll go ahead, get our LEDs in as well as our, there we go, Tsaw and our LM7805, which I think we will do now because I want to see what kind of room we actually have when we do put that in. Let's see here. So can I actually just bring that out a bit for you guys? There we go. That should be a little better. And then we're just going to go ahead. Hopefully be able to just go like this, solder it, and then we'll bend it back. So that's the goal. Will it happen? I do not know. So I'm just going to go ahead, get one of them just started. Enough to hold it, and then we can go around, do the other 2 pins on there, and I wonder if I can actually turn this down just a little bit here. Maybe we can actually bring that in a bit. There we go. Maybe something like that for a moment. Don't ask me, I'm not a pro at this camera setup thing yet. Still learning it. So there we go. And we're just going to get this guy on. This guy on. Perfect. soak in. Done. I'm just going to bring it up the rail a bit there. I'm going to go ahead, get rid of a couple of these guys. Just bring this up a little bit. And we'll flip it over. Well, it's not perfect, but it's definitely lower than it was, right? I definitely maybe should have bent those pins and then arched it down. Good to know. Good to know. So I kind of messed that one up. And then now we have our Tsaw. I'm just going to plop that in. But this one I do want to actually have it laying down. So we're just going to go ahead. We're just going to find out where it wants to go. We want to stay away from that resistor there. So I'm thinking like that. That would be perfect. So I'm going to go ahead and solder that on. I think what I can do, what I will do, is I'm just going to solder a little bit on top here. Like that. And then that should hold it enough that we can flip it over and not worry about it dropping. Perfect. Look at that. I'm just going to flip this around now. So there we go. That way I can actually get to it. And then we're going to go ahead, solder this guy on, solder this guy on. Done. Alright. Trim these guys out. And then we're going to go ahead, we're going to place our LEDs, and then that's it. Besides setting up our 9-volt. So for today, what we're going to do is we're just going to run that connector, this guy here. We're just going to run this one in here for today. And like I said, I will 3D print a case for this at some point. As of to when, I'm not sure, but this will at least allow us to test that out. So we should be able to test this out and yeah, see what happens. So I'm just going to go ahead and place my LEDs. Okay, so what I want to do now is just solder on my LEDs here. So I'm just going to actually try to hold that up. Beautiful. Well, that should do the trick. And here we go. Alright, do something like that. Don't bridge the connections. That is. There we go. Two. And I'm just gonna. Last one here. these guys off. And same as these ones. And then we'll just verify that they're flush on the other side there. Looks pretty good in my books. So all we're going to do now is we're going to attach the 9 volts here, and then we're going to quickly solder on the switch to turn it on and off. So right at the moment here, if we did use the RF, we should be able to get the LED to turn on. Slide in our tester here and get you in focus. Okay, so now if everything is done right, we should be able to get an LED to flash. And there we go. By holding down that button, we're charging up those diodes. So it looks like my sweet spot is just on the edge of the board here. That's producing a nice jump there. So perfect. We've got that guy working. Now we need to get the infrared working. So to do that, I need a little bit of wire, and we're just going to make a couple of leads to our switch, and then we're going to solder in this guy here, our 9-volt battery terminal, which, you know what, let's just do that. Let's do that right now. Okay, so I'm just going to put these into here. Negative there, positive there, and all I'm going to do is I'm going to try to just tap it with some solder. Let that go in there. I'm going to do the same on this other one. Not too worried about making it pretty. Yeah, sure, hit the wire. But as long as we're not bridged, this should be fine. So now we've got that soldered on. We just need to get 2 wires to go from there to our switch. So I need a little screwdriver, which I might have. I might need to find something smaller, and I need some wire. So luckily I have no shortage of wire. So we really don't need a huge amount of wire for the switch, but so all I'm going to do now is I'm just going to take my wire here, and I'm going to go ahead and get that stripped, and 2 of the connections put onto my switch there. So I'm just going to go ahead and strip those wires down on both sides here. We don't need to take too much. There we go. Twist them, tin them, solder them, do what you got to do. And with these ones, we should be able to just twist them and put them into the terminal there, and then we'll just solder it to our switch. And basically all this is doing is just cutting current to the switch. Oh. And yeah, or cutting current to the rest of the circuit, and we will go from there. So this is definitely a lot longer than I was expecting to do, but that's okay. This is the fun of making. I should definitely maybe start doing some Twitch streams. I just find I don't have that much exciting things to talk about, so I don't. but maybe I'll just do a couple for fun, and maybe we can learn something together there. Because I find a lot of people that use Twitch, they get a lot of help from people on there. So that sounds like a great idea and a good opportunity to learn something with others and teach a little. Alright, so I'm just going to go ahead, I'm just going to solder this onto my connector here. So this is an on, off, on switch, since we're only using on and off. It's not a big deal. I'm just gonna try to just rig this up a little bit here. Yeah, something like that. We'll go like that. Try to poke this one right here, and then I'll bend it over. Alright, so what do we got here? A lot of wires going on. There we go. Okay, so I'm just going to solder that up. Oops. Okay, so that should work. I've got that soldered on, and all we're gonna do is just connect it into each of those wire holders there, or the wire terminals here. I'm just gonna go ahead, and of course it's too long, but that's okay. Or my screwdriver's too wide. Do I have anything smaller? I don't know. Probably not. Or I probably do. I'm just being lazy. So we'll grab our kit. Okay, so I decided that it's now the next day, and I thought I would go through and put together another one of my boards to see if it would work or not, to make sure. It would have been as simple as pulling a couple components and testing them, but I figured, you know what, I got more boards, let's put a bunch of new items in there and see if it works. So let's have a look and see how well it turned out, and I'll explain a bit as we go along here. So here we go. Here is the completed board. As you can see, a bit has changed, but not too much. There is one thing I need to do, and that is to swap my ends here for my switch here, just because it would be put in backwards right now. So we want to get that fixed so it actually cuts the power correctly when we switch it over to off. Right now it's not, but that's not a big deal. It's the fact that we've got it working now. So what was happening was either one or the other would work, and I wanted to see what was going on. So I don't know if something was interfering or if I need to come up with a better design for this board. Just because there is a lot that obviously I'm not doing correctly when designing these things, but that's okay, because that's what it's all about, is actually learning. Let me see if I can get this a little brighter on you guys here. I got a bit of a shadow here. There we go. Let's try. I have no idea. Anyways, so let's have, or actually I could go So now we can see that a bit better here. So the diodes here, this was just to put on there because I wasn't sure if it was going to work or not. So I figured, why not give it a shot, see what's going on. And this circuit did work, and what we'll do is we'll test that out right now with my trusty Baofeng radio here. So I'm just going to zoom that out. So I got my radio here. I'm going to turn it on.
Frequency mode.
And basically all I'm going to do is I am just going to press the button here. I got the antenna underneath the unit here. And basically what I'm going to do is I'm going to turn this a bit darker here. So now we should hopefully see an LED light up when I press the button on the side here. And there we go. As you can see there, I'll zoom in now. And there we go. And as you can see, there's enough interference from the radio waves there to power the LED. And that's perfect. So we have one way of testing these types of frequencies, the RF frequency. When it came to the infrared there, all I had at the time was one of these guys here, and I thought, yeah, that would work just for testing. Oh, sorry about the camera. This would work for testing. I do a lot of remote repair at work though, and like I said, it'd be nice to have something that I could just toss in my bag and away I go. And all I did here for now is I wired up a 9-volt battery, and I just put 2 male header pins on the board where the positive and negative is on there, right down in here. So as you can see, they're right there. So I'm just going to go ahead. I'm going to take my power cable here and plug that in. Come on. There we go. So we've got that powered on now. And if I press a button on the remote there, we should get a signal. And as you can see in the camera, it is flickering, so that's letting us know that yes, the button is working. So that is it for this one. I think that is pretty darn good for now. It was definitely a learning experience. It was definitely a fun project to come up with something that was actually going to benefit me in my day-to-day repairing. So I thought this was a really cool project to be able to do for the Element 14 Project 14 guys to see that you don't need much. You know, even a Raspberry Pi with fritzing on it. Go ahead, design your board. $5 later from JLC PCB or whoever has the best deals on. Get it printed. Pop your few dollars of components in there, and away you go. You have a fun unit. So make sure to check my post on element14.com on the Project 14 section there. The link will be in the description below there, and you'll see all my sketch, the parts list, and everything that you need to do to make your own project like this, and it's really not that much. And from there you can go ahead and progress and build bigger and bigger projects. So with that being said, I hope someone learned something today. Thanks for watching, everyone. You have a wonderful day, a wonderful week, and we'll see you next time. Take care, eh?